And hopefully this is starting up right and it's working right. So I'm starting about 10 minutes early for the video, but I'm not going to start the testing until I'm on the top of the hour. But I've had a lot of questions, and this is going to be a little bit awkward tonight because I'm going to sit under here when I test this tonight, and it's going to be hard for me to read my laptop is far away, but I'm not technically starting any testing until 8 o'clock. But I've had a lot of emails and questions if I could post a little bit more about the facts of the plane. And so what I'm going to do right now before I start at 8 o'clock is go through some specs on this plane, because I've had some people asking some questions about, you know, what is the real wingspan, what is the square inches, what is the wing loading, and all that stuff. So I'm going to do that for the first couple of minutes before I start at the top of the hour. And what we're here to do at 8 o'clock is I'm going to see how much force this door can take, and I'm just going to physically grab it, I'm going to bind it, I'm going to move it around, I'm going to shake it as I'm cycling it, but I'm not going to start that until 8 o'clock. And we'll go from there. So I'm just making sure my video is not lagging any. So essentially, the plane has a 216-inch wing, which is 6,499 square inches. Okay, the height, the horizontal stabilizer is 84 inches wide, which it has to be under 86 or it won't fit in my trailer. Its square inches is 1,668. The vertical stab right now in the design, I'm not locked into it, is 36 inches, which is too tall, because if I ever put a large space shuttle on the back of this, I don't want to have a big tall tail behind it to hit. So I'm probably going to go to dual vertical stabilizers, but it's going to be on the sides of the fuselage here, not out like a B-24. It's actually going to have a smaller stab here and a smaller stab there. Vertical stabilizer. That way I keep it low, because I'm going to build a space shuttle not anytime soon that will fit on this, that has a 140-inch wingspan space shuttle. The fuselage length is 157 inches long. The tail height will be 63 inches tall. So if I'm standing next to it, when it's sitting on the ground, this right here is 60 inches tall, so 63 is going to be about here, so it's going to be about as tall as I am when I'm standing next to it. If the plane's at 60 pounds, the wing loading will be 21.27 ounces, or a cubed wing load of 3.2. If it's at maximum weight of 77 pounds, it will have a wing loading of 27.3 ounces. Which is really low, which is a cubed wing loading of 4.1. So if you're just coming on now to the video, I'm not starting the testing yet. I'm just talking about the specs on the aircraft, because I've gotten a lot of emails asking me to cover that. The watts per pound when it's at 60 pounds will be 140 watts a pound, and when it's at its maximum weight will be 109 watts per pound. And if you watched my other videos on testing watts per pound, my first MSL at 6 pounds, had a wing watts per pound of about 80. All these people on the internet said it would never fly. As you all know, it ended up with over, I think, 500 flights, and you had to fly it like a real airplane. It flew on the wing. So that's the stats on the airplane. The 4 motors are going to be the Hacker A60-16Ls. I'm expecting about 2,800 watts per motor, so that's over 10,000 watts for the whole airplane, which is pretty kick-ass. And it has air brakes on all 8 of the main wheels. You know it has dual steering nose gear. There's no retracts on this. It's going to have 2 receivers. It's going to use S-Bus. The 2 receivers are basically going to divide all the systems up into half. Aileron on one wing will be on a receiver. Spoiler on the other wing will be on that same receiver. That way, if I lose one receiver, I still have my roll axes controlling from the both left and right wing. The elevator is going to be 2 elevators. One will be one receiver, the other one. The vertical stabs will be one on the other. The throttles will be split between the 2 receivers, but they'll be split from front to rear engines. That way, if I lose one receiver, I just lose the 2 front or the 2 rear engines. I don't lose the engines on one side or the other side. And my servo count still is around 36 servos on this. I'm not done yet. And as I've mentioned before, I've already tested the leading edge devices. I've tested the spoilers on the wings. I've tested the flaps. I've tested the landing gear, and you've seen that. And good evening, everybody. I see people popping in here early, which is cool. If you're logging in right now, I'm just going over the specs of the airplane because I've gotten a lot of emails before I do this test tonight. And you can watch the video from the beginning, but basically I just covered what the wingspan and all that stuff is on the airplane. Somebody sent me an email to ask me if I'm still on time. I'm very close to being on time. I know that the other horizontal stabilizer I can build in a day. I know the 2 outboard, well, 1 outboard section of the wing was the very first thing I built as a proof of concept. So the other wing will be easy to build. The center section with the nacelles is going to take a little bit of time. But I still think by the end of January, maybe the 2nd week of February, in that 2 weeks time span, I will have the plane basically ready to paint or painted. A lot of controversy about the paint. A lot of people say I should paint it white, make it look like a NASA aircraft. Some people want me to paint it silver, make it look like a Strategic Air Command. I want to do a camouflage to make it look like a German transport that never made it into service before the war ended. And I'm not 100% sure that's what I'm going to do, but I'm thinking that's what I want to do. And I'm almost positive I'm going to do that. If you watch my other videos, you already saw that I'm going to cover the entire plane in, well, hang on a minute, let me back up. There's going to be certain parts of the airplane covered in 2.5 ounce fiberglass for strength, and it will use West System epoxy. The rest of the airplane, just so I have a painting surface, will be covered with 0.75 ounce fiberglass with water-based polyurethane and latex paint painted on it. And then I'm going to take regular Krylon clear semi-gloss and use that to seal the entire thing when I'm done. Because clear goes on so thin that 2 cans will almost do this whole plane. But if I painted the whole plane with can paint, it's going to take like 25 cans. So we're close enough. I'm going to go ahead and get started on this test. So really what I'm doing here, and this is going to be a little bit unorthodox because I know a lot of my testing guys, I've made like vibration machines and tension machines. I'm just going to take my hands and yank on this thing. So I basically want to know what's going to happen if turbulence and stuff are hitting this door. So what I'm going to do is cycle the door. And just start shaking the crap out of it. Trying to hold it back as hard as I can. Oh, look, it's moving my table. So right now, I'm actually surprised it's as strong. So I'd say my door's pretty damn strong. Actually, I'm surprised I didn't break anything. Keep in mind, this is a prototype door. Everything was 3D printed except the foam and a little bit of balsa wood here. I did put a piece of aluminum to stiffen where the arms grab it now. just so you understand what I changed in the design from yesterday. This jack screw here used to have two small arms that grabbed the back right here. And when that jack screw went to move the door, hang on a minute. So essentially what would happen is if this is the door, I had the little arm come down on the jack screw up here. And when it went to start the door, it was pushing down like this, if you can see that. And that is a really bad force to have on it. What I thought about last night after I tested it was, what if I went from the jack screw, what I call a shuttle that moves up and down it, and just ran it all the way to the front. So I've got an arm now that runs from about here all the way to here, grabbing it here, and that's what makes it strong. So I'm going to cycle it back now. Table. That's absolutely amazing. And it hit its limit switch and stopped. So, actually, I'm amazed how strong this is. I thought it would be really, really strong. And I knew the moment that, that angle that I had that arm probably wouldn't work, and it didn't. But I think right now it's kick-ass. I think it's ready to go. I did have a couple of questions, and it was kind of amazing. I got both of them. Let me make sure the camera can see me here. Is what happens if there's twisting forces on the fuselage while the door is moving? So let's see. I'd say it's pretty good. Actually, if I had a camera looking down the front of it here, you'd be able to see the fuselage twist about 3 to 4 inches when I'm doing that right there. So once it's glass, I don't think it'll move that much. Isn't this sucker going to be cool when it rotates to take off? So I feel really good about that test right there. And hopefully there's not much latency here, and you guys are all seeing that. Yeah, no, it looks like everything's coming through really good. Yeah, it hit the limit switches, so it's working perfect. So I think that's done. Basically what I'm going to do now is cover this, and yeah, I really am proud of this. That's amazing that door is as strong as it is. You know, here's something to think about. Is when I first started playing with ABS, I started realizing that most of the success of the ABS is the direction you're doing the layers. Because think of ABS like the wood grain of wood when you're building. If you break a board across the grain, it's weak. If you try to break it, if you break it with the grain, wood is weak. If you try to break it across a grain, wood's very strong. ABS is the same thing. the original small arms that I built were these little ABS arms right here, and they weigh virtually nothing. And but yeah, it's not the B36 cool. But you know, the thing is I couldn't do all this neat stuff without the 3D printing, and these tracks are a lot stronger than I thought they would be, and they don't weigh hardly anything. So I think I'm done testing this. I think I'm going to work tomorrow on the horizontal stab. If you haven't been up to speed on the stab's actually going to tilt. That's my trim for my airplane. So instead of using my elevator's trim, I'm going to have the entire stab moves trim. The reason I'm doing that is I read a NASA white paper that was talking about some of the large jumbo jets. The reason that whole horizontal stab moves because the Mach number, but also because of how far the CG moves around on a jumbo jet, because of people and cargo and all of that. So I started thinking about this big old long ass fuselage. If my CG's going nose heavy, I designed the airplane that's going to be very hard to go tail heavy, or the cargo would fall out the back of the airplane. So this airplane has a capability of being very nose heavy. And to be very nose heavy, I don't want to just use my elevators as the trim, because technically you can take an elevator up high enough that it starts to become inefficient. So by making my horizontal stab tilt as my trim, I think the plane can be really, really nose heavy and work. So if you're just popping in now to the video, what I covered was some stats on the airplane, so you can watch it from the beginning. Basically the wingspan, the square inches, all the data on how big this monster is. And I just tested by trying to tear the door basically off the airplane. I tell you, if this jack screw's got enough strength to actually move the table that the plane's sitting on, I don't think I'm going to stall that jack screw. I was afraid it might break something, but nothing broke. So this wasn't going to be a long video. The videos I'm going to do this week, since I'm on vacation, one's going to be on some electronic stuff. One's going to be, of course, on the horizontal stab update. I'm trying to put together, everybody's asked me about my little flux core welder that I use, and my MIG welder, my flux core MIG welder. So I'm going to do a little thing on welding sometime this week. So, you know, I have 4 or 5 different videos that I'm wanting to put together this week. So that's pretty much all I want to do was this testing. If you're just joining in now, we're at the end. And you can watch this, you know, once I log off it, then you can watch it from the beginning. And I'll probably be back on tomorrow night. So that's pretty much it, everybody. I'm really super excited with how strong this door turned out. And a little bit depressed that I didn't design retract landing gear now, but this plane's supposed to be super simple and easy. So thanks for watching, everybody. You have a great night and be safe. Take care, everybody.